Good morning, everyone. My title, I added 2 times unexpected as a new signature in astroparticle physics by using planetary relationships which should not be there. Even better if they should not be there twice. And in the next slide, I cannot continue, I can. I give you some references which will be used throughout this presentation. And I'm glad that in between we are in a quantum state of a startup collaboration with Dima and his people. They ask various questions all the time, and they scrutinize which is good and not good at the same time. So the principle of this work or this approximation goes along ZWICKY, who discovered dunkle materie because he has made some strange cosmic observations which were not expected. And then the question arises whether we have a lot of anomalies and mysteries locally meaning not minds but the solar system, and they insist, and we don't know where they come from. We will see some examples. And the question is whether this is the trigger or the signature from the dark universe. So the sun has a dynamical behavior which is in itself a mystery, or even though it should be a nice body, after 4.5 giga-years it should have been in a thermal equilibrium, and this is not. This is the strange thing. And I recall a recommendation Frank Wilczek made once in a seminar at CERN: focus in your work on anomalies and mysteries, so to find something new. So we started with years before, but it was a confirmation, so to say, by Wilczek. And so the first thing you realize when you look to the mysterious sun is a simple thing. If you look to the temperature from the core, it goes down from 16 mega to 6,000 Kelvin. And then for some reason, you cannot explain, to the best of my knowledge, there are 50 or 100 models. The temperature of the sun all of a sudden goes up. All of a sudden means something like between 110 and 100 kilometers. The temperature rises by 2 and sometimes by 3 orders of magnitude. This is the corona, and how it comes about is the mystery. And this is the guy, the German, who has found it. And the solar corona has, you can see his manifestation another way. This is the analog spectrum from the sun. Here is the photon energy, and here this one is the thermal distribution at a peak of divisible of 1 eV or so. And then all of a sudden above 20 eV, you get this shoulder here, which should not be there for a thermalized body after so many giga-years. So this radiation is not expected. Okay, once we say is not expected, and then from it took 15 years for us to say, let's look what happens with these photons. And then we looked what you do. You look to the time distribution of something when you don't know, to try to find something. And we did this here by doing a little trick, projecting the daily density on the longitude, on the orbital position of Mercury. You try everything. So this was maybe the 100th try, but for the talk it was the first try and the first spectrum. And then instead of getting something random here, these mysterious things gives you three peaks. So this was, let's say, the first planetary dependence of something mysterious. So this was not expected. This I cannot tell you how these peaks come about. I cannot tell you yet. Okay, the idea is that one day you come about and be able to explain what happens here and there to have the 3 peaks. So this is the first planetary relationship, the first planetary spectrum was mentioned in the title of this work. So the paradox becomes then paradox squared. It's good if something happens. But it is not quite true if I said we measured this for the first time. 50 years before, some big, with 2G from Australia. Australia has a good physicist like Tobar and his people, and he has done the same thing we have done here with the UV and above. He has done projecting the number of sunspots per day. And he got this nice spectrum here, the continuous line, observed. And then you say how the Mercury can have an impact on the source of the magnetism on the sun and have such a straight distribution. So there must be a force between the planet and the sun. There is, however, only one force then and also today, which you know, the known physics tells us, is the gravitational tidal force. The gravitational tidal force goes with 1 over r cube and has such a distribution. So this guy was then disappointed because, okay, he could explain this peak, but not this and this. So he was disappointed and said, no simple theory will entirely account for this complex pattern. I agree with. So this was good because this spectrum here, it was encouraging because it was a confirmation of our spectrum, even though confirmation done 50 years earlier. Okay? So that's why from there on, I believed what we have done there, we can do something wrong in Fortran or whatever you use. And then the first takeaway we have is that a peaking planetary distribution excludes by default any remote force. In that case, any remote planetary tidal force. And as I said, this was a confirmation for this work. And then I will show various cases, rather extreme cases, and the strongest one. We move around in the hope someday to be more conclusive of how this staff who does this job looks like on the microscopic scale. We don't know yet. So the 11-year cycle is something you have it everywhere in the solar system, whatever you are doing. And people, when they realized this immediately after some 160 years ago, they said, okay, these 11 years must have to do with 11.86 years, the orbital period of Jupiter, because it is very nearby with 7%. So Wolf, a big name in astronomy, said in 1859, the variations of sunspots must depend somehow on the position of Venus, Earth, Jupiter, and Saturn. Even though I think Venus, Earth, and Jupiter is enough, but he was better, and he took also Saturn. Saturn plays also always a role. The point was, however, that then and also now, that following known physics, these remote tidal forces are by far too weak. There are missing some 11 orders of magnitude. So it is hopeless, but people come back and again and try to make some tricks and find some explanation. But sooner or later they give up. So these 11 orders of magnitude of missing, of being something nothing, you cannot bypass easily. We look further. Yeah, so then you won't come with another scheme. So the other scheme you want, you must arrive to a point that you arrive to a procedure where that it pretends a remote interaction, which is not there. But this must give you also something looking so as if the planet X has does interact with the sun. We say only in this combination. For this, we were forced, so to say, to assume that streaming invisible matter, to distinguish it from dark matter, we know which is axions or WIMPs. Actually, axions, if you ask me, but let's say axions or WIMPs to be polite with all participants. And then assume gravitational lensing, it's not a problem. And also strong interaction. Strong interaction meaning large cross-section between these constituents of the invisible matter and normal matter. And the planetary lensing deflection is given by this formula, and here stands c squared denominator. So this, you always think it is something remaining from mc squared. No, it is not remaining from mc squared of some mass. It is a pure c squared, meaning velocity. Oh, Fritz. So the deflection goes with 1v squared, meaning for dark matter constituents, you have a big advantage. You can have a very short focal lengths, and then planetary lensing is possible within the solar system. And even more, planetary lensing you can have from the moon towards the Earth. The moon can focus towards the Earth 400 up to 500 kilometers per second, so it can focus actually all the dark constituents we are talking about, but I stress that it have been overlooked in the dark matter research, that if dark matter is made of streams, then we have problems with the we must take this into account because of the planets surrounding us, and also including the nearby moon. And we say that dark matter does not emit, absorb or reflect electromagnetic radiation, and this might have been misleading, as with these cases we have shown already, and we will like solar flares. You cannot predict a solar flare because you don't know his mechanism. So we have seen peaking distributions for solar flares, and also for the radius of the sun over 21 years. We have seen also planetary dependence, and planetary dependence we have seen also for the upper atmosphere. This is the stratosphere, and also from the ionosphere we have seen also planetary dependence, which are large. The largest we have had is a factor of 6 between minimum and maximum. And also we have seen for earthquakes planetary dependence here. That's the thesis, fresh thesis of Dr. Marius. He sits somewhere here. And with the Fourier analysis, we see a line at 27.32, which is magic line because it is the geocentric motion of the moon with reference to remote stars, to something outside the solar system. So this must have to do with something outside the solar system. Makes the whole story more magic, if you want. And recently we could get from NASA in a very fast response that the flares, the quakes in the Mars follow also a planetary dependence, which also should not be there. This has been confirmed by others, but unfortunately before us, but we insist on this study to be next time in front of the others, we hope. And then the other extreme case was and last one, the melanoma. That's to little society relevant. We have seen there two peaks, the one at 88 days within less than 1 sigma, which is the periodicity of Mercury, and the other one from data from Australia, daily data. These were mean month values. Again at 27.32, the melanoma in Australia followed the moon with reference. And this one we could also confirm that this was really exosolar in origin when we compared we compared melanoma with the daily proxy of the solar activity. They are completely different in shape, and in minus 14 here percent, and here plus 65%. And having said that, I come to a paper and finish from CQV about clean dark matter from last year. And what I can only say that we should follow up this. With these various peaks we obtain at positions. For example, in stratosphere you get it. Below you don't get it, peaks. Whether there we can select place and times to have an enhanced density of dark matter and eventually gain more energy than CQV calculated with the cast limits we have from Axions. That's all I think at the moment. The conclusions you can read here, and I close and thank you for your attention. Thank you, Mr. Chairman.
Well, dear Konstantin, I thank you very much for this talk, really at the cutting edge, and yourself standing at the edge of the cliff.
I am at the edge, yeah.
Which really worried me, and because I know you, and maybe a little step back is not so good. But we have some time for questions and comments, and so, Johan.
I can shout, but
Professor.
So I have actually two, because the chairman will so one is actually a curiosity. You showed the melanoma slide.
Yeah.
And I understand the 27.2 peak.
32.32.
And there are two other huge peaks, 28 and 29.
Yes.
And I would like you to comment on those. And the second question is one that I always ask you privately, now I ask you in public. What is your idea of the interaction between, say, Mercury and whatever else that might be at the seed of this?
Professor, question first. So, this this other line there, 28.1 is God given. It is a subharmonic of the 1 year which falls there and gives you a calibration line of what you plot there. It's a fantastic line. So you trust what you see links left and right because you have the calibration line just in the middle. Okay, one question and one answer. Now the other question you ask, not yet, I cannot answer yet. However, my feeling is that dark matter or invisible matter, as we call it, must be something huge, not something interacting with 10 to the minus 5 per kilogram per day or per month, etc. It must be some massive going around here in our neighborhood. This is my feeling. And following this feeling, you select some also specific cases to investigate. It was not random that we investigated ionosphere and then stratosphere, etc. And the earthquakes. The earthquakes, you know, ZWICKY and others, I think, they have made a paper that they softly say they can also produce or induce an acoustic or even seismic effect. But again, this is not to say I put dark matter and then the effect is tiny. If dark matter plays the role, and something like dark matter must play the role, it cannot be something visible, that's clear. So the point is that what I want to argue, yes, it triggers you. It does not give you all the energy of an earthquake or all the energy in the change we have we measure by helioseismology, which is macroscopic 10 to the 30 erg. 10 to the 30 erg is 10 to the 42 EV. You don't put 10 to the 42 EV in 1 nanosecond or in 10 seconds into the sun. So it is something, it is a procedure there which grows up in time. So, but the answer is rather, I don't know yet. And that's why we look at extreme cases just to encircle it. But we are in the darkness yet.